All right, so let's see if we can find an exact value for the cosine inverse, sorry, the sine inverse of the cosine. So I'm going to rewrite it. I prefer to call it arc sine. So I want the arc sine of the cosine of pi over 4. Now, if I plug this into my calculator, it's probably going to give me a decimal and not an exact value. So let's see, what do I know about the arc sine and the cosine? Well, I know the cosine of pi over 4. All right, think unit circle for a second. Pi over 4 is that 45 degrees there. And I get square root of 2 over 2 for x, square root of 2 over 2 for y. So the cosine of pi over 4 is the square root of 2 over 2. So now I can say the arc sine, square root of 2 over 2. And the arc sine, again, basically says the sine of what angle is the square root of 2 over 2? Oh, well, that's the y value, that's the angle. That angle has to be pi over 4. So that should be the exact answer. Now, will the arc sine of a cosine for any angle always be the same angle? The answer is no, it depends on the angle. If instead someone said, find the sine inverse of the cosine of pi over 6, let's do that in red over here. Pi over 6 would be over here-ish. And for that point, I get the square root of 3 over 2, 1/2. So let's think about that for a second. Cosine of pi over 6 is square root of 3 over 2. So now I want to know about the sine inverse of the square root of 3 over 2. Well, another way to think about that is the sine of theta equals the square root of 3 over 2. So what angle on the unit circle has square root of 3 over 2 as the y value? Oh, well, that would be this point up here. That would be the point 1/2 square root of 3 over 2. And that angle up there is pi over 3. So then the sine inverse should be pi over 3, not pi over 6. Okay, so just because we picked pi over 4, the answer came out to be pi over 4. For any other angle in here, we're going to get a different angle outside. And if you want the exact answer, calculator is not necessarily helpful. And again, you can check this on a calculator.